All right, so we're Team Foresight. We built the product known as Software Citation Tools, and we're here to talk to you guys about that. I'm Robert Lowe.
I'm Sam Mosier.
I'm Colin O'Neill. I'm Eric Lee.
Our faculty advisor, who just ran off to go find our sponsor, was Dr. Donald Boyd, and our sponsor is Abigail Mays of the Mozilla Science Lab. So our project was primarily focused around addressing the issue of software being cited in research, specifically the issues with it not being cited in research. We've discovered that often software gets miscited as data, as a paper that describes the software, or not cited at all. This causes a lot of issues in academia where it makes it a lot harder for you to reproduce code or reproduce work when you don't know what was used to produce the work in the first place. It doesn't credit open source developers who really sort of need that understanding of how important their software is. We're running into the worry of what would happen if an open source developer sort of wrote this library that they thought nobody ever actually used, but actually is critical to an entire field of science, and they were just like, nobody uses this, I'll just delete this GitHub repo, and they just destroy an entire set of research based on that. So we're sort of working on that. So we based our citation attributes off of a Force 11 working group's paper about citing software in research. Specifically, the primary concerns of attribution, specificity, accessibility, persistence, and unique identification. We provide attribution through providing the title of the repository and the authors who contributed to it. We provide specificity by providing the version number and release date, which is really important because if you don't provide those, you can't pull the exact version of software that was used. We also provide a URL and a DOI if available, which both provide access to the software, but the DOI also provides access to persistence and unique identification because it sort of snapshots a repository. Our sponsors' needs, in addition, Mozilla Science Lab is an advocate for open source software and science, so we're targeting specifically open source repositories. These are also the easiest for us to read metadata from. So we talked a lot to a lot of different researchers through our connections with Mozilla Science Lab and also people that we reached out to on our own, and we discovered that the three primary sources that we are focusing are GitHub, Bitbucket, and Figshare as being the most used in the research field.
Great. So now we're going to briefly go over the high-level design and architecture of our system. So really quick, what our product is meant to do, this is dictated from our requirements. On the left-hand side there, we have a URL to some sort of code source. As Rob said before, we are supporting GitHub, Bitbucket, and Figshare. And that URL is the input to our citation tool, which then takes that in, determines what code source that URL belongs to, goes out to that code source, fetches any sort of related data to that code source, formats that data into a citation, and outputs that citation depending upon the individual tool. And you can also input how you would like the citation to be displayed. So we have our product line here. The product line includes the plugin, the web app, and the command line interface. Those are all built on top of the citation core. So this is a common framework that is responsible for going out to for determining what URL the code source or what code source the URL belongs to, going out to that code source again, fetching that data, and then formatting that citation string and giving it back to the individual product line or individual product, and then the product determines how to display that. So it's a shared code base across all of our products. And that is built on top of Node.js, which was a requirement of our sponsor. We are supporting a plugin, and you can't really run Node.js in a plugin itself. However, it's still JavaScript. So we use Browserify to kind of, we ran our code through Browserify, and that spits out code that can be executed within the plugin. So that's kind of cool.
All right, now we have the demo. Let's see. So here's the web app. You can cite all three sources, so you can cite Bitbucket, which is grabbed from this page. You can cite Figshare, so you just grab the URL. Didn't actually copy and paste, okay. And you can cite that. And you can also cite GitHub. But GitHub, I think we'll have to log in. Yep. So GitHub, we had to actually implement OAuth. So just log in real quick, because GitHub actually limits the amount of requests that you can do. Yeah, and so you can cite that. So then this is a BibTeX actual citation type. So you can log in here. And this will just demonstrate that it actually produces a usable citation. Yep, and you can see down there, it's actually got a citation. And we also have the plugin. So the plugin, you're actually able to do two things. You can just navigate to the page that you want to cite, and if you click cite, it will actually bring up the citation. And so there's an APA one. You have you have the 4 different types that we support currently, and those are easily added on top of just with simple changes. And then you can also cite, once again, all 3 different types. Or you can go and you can actually take the string on any web page and cite it. And then that brings back the actual citation. And that basically concludes our demo. Let's see, where's full screen? There we go.
All right. Some of the challenges that we faced while developing this suite of products. First of all, we found that there was a limitation with some of the APIs. For example, within Figshare, authors, because Figshare is designed to be a repository for all kinds of research and documents, and isn't as focused on software as the other two, they don't have a email field, and so there was no way to pull emails from Figshare, where we wanted to have an email associated with the author. When you're citing a Figshare site, a Figshare source, you can't pull that email. Similarly, there's no list of contributors on Bitbucket, which led to some having to parse through the entire list of contributors in order to figure out who the top contributors were, since most citation formats do not list every contributor. They list usually the top 1, 2, or 3, and then have an et al. Or something similar. So we had to manually determine which contributors are the top contributors, and there's some debate in the field about what exactly determines a top contributor. We had to go, for Bitbucket, we decided to go with number of contributions. And obviously in a large active project, or a large active open source project that has, thousands or even tens of thousands of commits, that can take a little bit extra time in order to determine those contributors. And finally, the sources that are not as focused on research, specifically GitHub and Bitbucket, have no field for a DOI, which is the unique identifier often used in research. Figshare does have it, but GitHub and Bitbucket do not. And really, even without the API, there's no way to manually determine a DOI. The only way you could really associate a DOI with a code repository in those is to put it in a documentations folder or in the root directory of your project, which would obviously be difficult to determine. Hey, is that a DOI? Can we pull that out? In addition to the limitations of the APIs, we also had trouble fostering a community and soliciting contributions to the project. This was built as an open source project, and one of the main goals our sponsor had for us was to foster a community around this product. We were able to get some interest in using discussion issues on GitHub, and we got some feedback. We engaged with a few different people, but we were never really able to get a consistent group of people who were actively contributing ideas or code contributions to the product. And we believe that was due in part to our inexperience with managing open source project. We tried a few different methods of reaching out through email and social media and whatnot. But in the end, we weren't able to foster a community before the end of the project. And this created a bit of a problem for us because we had a project where the requirements were meant to be driven by the community, and because we failed to foster as robust a community as we would have liked, we didn't necessarily have as many people to go out to and say, hey, what should the requirements be? So the first future goal we have, if this project were to be continued or brought back as a senior project with additional goals in mind, it should definitely be a top priority to continue to try and foster a more active community to contribute to the tools. This would also help with the longevity of the product, making sure that it continues to be usable. We also started, but were unable to complete, a stretch goal of supporting parsing the .git folder for data. The idea behind that would be to pull down a temporary copy of the .git folder of a project, basically making a headless clone, and use the metadata that you can pull from Git in order to create the citation. What that would allow us to do is not have to worry about which values the API allows you to get, and it would also allow us to use any Git repository as a code source, not just Bitbucket or GitHub. So for example, if a university or another research institute had a private Git server, you could use that as a source. Furthermore, you could, if a researcher had pulled down a Git project and used the program and then still had that on their computer, they could use the exact copy they have on their computer to generate the citation, therefore making sure that the version and everything else was exactly what they used. Finally, we'd like, in the future, you could add additional version control systems along the same line as the .git folder parsing to support things like SVN. As was mentioned, we made the product pretty robust for adding different code sources as well as different formats. So it would be fairly easy to add additional code sources and output formats. And that is it. Do anyone have any questions? Yes.
How are you parsing the .git folder?
How are we parsing it? Yeah, so we look at the, right now we don't support individual specific versions of a particular code source, but we would look in there and there's a heads file, and that has a hash to pretty much the first commit there. And then that has a link to the next one, link to the next one, so you go through like that.
So you were manually creating a Git folder.
Yeah, and that takes a long time. Yeah.
There were definitely some problems with the idea of the .git. It was an idea to make it more robust to be able to support more code sources, but as we said, it was a stretch goal that we ended up not having time for because, as Eric mentioned, it's pretty complicated to do.
How are you picking contributors or authors for Git, like on Git repositories?
Git. So what Git currently does, Git actually has a contributors list, and it's the top contributor. Yeah, GitHub.
Okay.
They actually have a top contributor list. For Bitbucket, we had to go through all the commits for the repo and
So,
build
for
that.
example, Linus Torvald is
Yeah.
Linux, right?
Yeah.
And so he wouldn't be listed, I guess, in that sense.
Yeah.
Because he's no longer as contributing.
So there's this is an actively debated topic within the community, whether you should use number of lines committed, whether you should use number of commits, whether there should be some
other way of determining who the top contributors are. Right now, if you're doing it problematically, there's no real way to say this guy absolutely was the number one person. You can have a project lead who everyone in the project would agree should be the number one person on your citation, but never made an actual code contribution. So when we were at MozFest, we spoke with a lot of people about this, and one of the ideas that was out there that a lot of people seemed to like was to create a sort of a standard where you would have a contributors document in a certain format, similar to how you have a README or a license file in your top-level directory. And that contributors document would list the top contributors and potentially what kind of contributor they were, whether they were a coder or a manager, etc. But until a system like that has enough adoption to be considered a standard or at least a best practice, there's no real way to pull that.
Yeah, we discovered a lot of different opinions on how that worked too. There was what was it in the astrophysics? They actually don't even list it. They never cut it off. It's just alphabetical. Every single person that actually did it. It's like pages long. So we discovered that everybody has a different opinion, and we can't make a general purpose solution for it.
Any other questions?
I was curious, kind of on a related note to that, actually. So one of the points of a citation is like that it's always correct, right? Like I can look back at a historical document that has this citation and be able to find exactly that same version. But the problem with this contributor system would be if you're doing it dynamically, every time someone generates a citation, couldn't that contributor list be different the next time you generate the citation?
It could be, but for the specific version. So if we went back to talking about how you have specificity, you want to be able to recreate the exact software that was used. So especially if you have something like a DOI, it's going to have a copy basically of the software in it. So if you cite the same version, it's always going to have the same contributor list, and therefore, no matter what system you choose to use, it'll have the same version of our software will produce the same contributor list, or the same authors, essentially, from the contributor list with the same version of the cited software. Now, if further down the line there is a standard that's adopted, a little more standard, and we choose, and whoever's managing this product at that point chooses to change this product, and then you went back and cited a piece of software that had already been cited with a previous version of this product, there may be a different authors list because how you determine the authors might have changed. Hopefully the other information, like the URL, version number, and if available, the DOI, provides enough information to still have a stable, specific reference back to the exact software used, but that is a challenge, yes. Any other questions?
Let's thank the team then.
Thank you very much.
Yep. Good evening, everyone.
I'm Colin. I'm Steven.
I'm Wesley.
And I'm Zach. We're Team Icebreaker, and we've been working on Project Glacier. Tonight we're going to start off by giving you some background information on the project that we've been working on. Then we'll go over the problem we were asked to solve, the solution we came up with, followed by an overview of the architecture, a brief demo, some design trade-offs, a reflection of the last 2 semesters, and some future goals for our project. Before you can understand the problem that we were asked to solve, we need to give you some background information on the sponsor's existing application, Glimpse. Glimpse is an iOS app developed by our sponsor, Mark. That makes it easy for people with limited technical skills or artistic abilities to take complex sets of data and create custom visualizations. It provides a simple and intuitive way for the average user to generate a custom visualization by making it easy to connect to different types of data stores and providing an intuitive WYSIWYG interface to modify the visualization to their liking. Recently, Mark has started working on the second iteration of Glimpse, envisioned as a cross-platform application with all the functionality of the iOS app. Originally, version 2 started as a native Mac application written in Swift, but our sponsor approached us with the goal of making it cross-platform. Mark came up with the idea of developing a library that lives in the JavaScript layer of the application, allowing for easy adaptation across multiple platforms. This is where our team comes in. Over the past 2 semesters, our team has been working on Project Glacier. Project Glacier is a library written in TypeScript that takes the business logic for manipulating visualizations out of the native application and into cross-compatible code. Glimpse 2.0 has always had a JavaScript layer for the final steps in creating the visualization output, but through the use of Project Glacier, the complicated state management and data manipulation code is able to run on other platforms while maintaining the native interface. We replicated a section of the logic dedicated to managing visualization state in TypeScript, with the goal of moving the responsibility out of the native code and into the browser layer. This is done with a JavaScript library that's authored in TypeScript for enhanced documentation, safety, and maintainability, architected with a unidirectional data flow, backed by an immutable state managed by Redux, built with Gulp and Webpack, tested in Node, and designed with browser environments in mind. Together, these enable our goals of future cross-platform portability, extensibility, and maintainability. Now let's talk about our requirements. In the beginning of the project, the team spent some time examining the technologies the sponsor wanted us to use and evaluating his needs to determine a viable architecture. During our first meeting with the sponsor, he gave us an overview of this existing application and some of the things that he really wanted to see in Project Glacier. Due to the fact that our sponsor was a software engineer himself, he had a very good idea of what he was looking for. This made the requirements elicitation process relatively simple. Our library handles all the data manipulation, formatting, and exporting for Glimpse. Based on the sponsor's requirements, it's written in TypeScript, making it cross-platform, has an event-based architecture, actions are cancelable, it supports Node, WebKit, and Chromium runtimes.
So, as we mentioned earlier, our architecture. When we started the project, we knew that we'd be managing a lot of state for the application. Specifically, we knew that we would need to handle user actions that are used to generate a visualization. Things like, I want to make the visualization larger. I want to add an axis that is a timescale axis. I want to add more data to the visualization. I want to make this the active field, so on and so forth. Anything you can imagine to configure a visualization, we would need to handle. On top of that, we'd also need to handle actually taking in data from the user and manipulating it in such a way that it could be suitable for rendering that visualization. And so in order to do that, we knew we wanted an architecture that could handle large volumes of state traffic, but still be easy to monitor for what it was doing. And so we templated our architecture on the Flux architecture pattern made popular by Facebook over the last few years. Its highlight is a unidirectional data flow through the central parts of the architecture, whereby data enters via action creators, which end up getting dispatched to a store, which then updates anyone listening on it, like a view, and then that can in turn create more actions. This has gone far to reduce the coupling in our system and make it easy to track just what's going on within the library, and has also made it easier to conceptually implement other features like undo stacks and other kinds of tracing operations. Our architecture specifically centers around the inclusion of adapters to specific data sources. This way you can load things like JSON documents, CSV files, Excel files, SQL databases, anything that you have an adapter written for, which handles communicating with a database and then mapping it into a columnar format suitable for joining with other data sources and rendering a visualization with. That also handles updating the cache inside of our model and other things. On the other end of our feedback loop, we have exporters which listen on the state and transform our internal state into the desired output format, be that an SVG, a zip file bundle with all the data, or an HTML document that can show the SVG image. Now, on the subject of rendering an image, that goes through what we call a generation pipeline. We take in, as I said, various user actions, database information, and so on, and then we maintain that over time. Our export process for an SVG image takes this internal state and maps it into what's called a Vega-Lite specification. That specification is a lightweight specification grammar for defining a visualization, defined by the folks over at IDL. Vega-Lite then takes that specification and transforms it into a Vega specification, which is a much lower level visualization specification grammar. So we have our internal state, which might be like 50 kilobytes in size. We map that into a Vega-Lite specification, which for comparison is probably around 100 kilobytes in size, and that ends up getting mapped into a Vega specification that's like 400 kilobytes in size. And then Vega can take that Vega specification and actually generate an SVG image using the D3 graphing library. And so, to build on this, we have our demo here for you. So first we end up selecting some active fields, we change the chart type to a line, update the description of our visualization. Then we add our first, we set the size. Then we add our first axis, which we've chosen a temporal axis around the bottom. Now then we add our x-axis and we have our line chart. We choose to edit it, filter the date to post 2000. And then once we've edited it, we decide that maybe the chart doesn't need to be a line, we go with a bar graph. After a bar graph, we keep on editing it, we remove the log scale, and then we make the x-axis ordinal, change the size, and there's a whole host of actions that we perform, this being an example of some of them. So as we change these actions, we're maintaining the state of this visualization over time and just getting in these little snippets about how each thing wants to be changed. The exact example of what our dispatcher takes in on the right-hand side. And this generates this visualization that you can get at any point in time. And that is the core of what our library does. So this wasn't without any trade-offs. So as I mentioned earlier, we were using the Flux architecture pattern, which typically contains some sort of dispatch for events. In the JavaScript community, there are a number of libraries that provide this kind of functionality base because a dispatcher is a dispatcher. It's very agnostic to what data you're working with. And we ended up going with a library called Redux because of its large community support and the patterns around it. Now, Redux incorporates a small amount of boilerplate into how we write our library. Actions, it's convention that we have action creators for them, which are just functions that return objects that make it easier to create the objects that get dispatched. And we end up writing these things called reducers that manage small portions of state and map these actions into new states for the application. So while our actions and our state are highly decoupled from one another, we do need to write a little bit of boilerplate code for that, and that is a trade-off we made. Additionally, at the start of the project, we were required to use TypeScript, but that in and of itself is a design trade-off. Nothing we're doing requires TypeScript. You could remove the TypeScript compiler from the project, delete the type annotations, and it'd all be valid JavaScript. And the reason we use TypeScript is to improve the documentation, maintainability, and safety of the project. The downside of using TypeScript is there is more technical knowledge needed to actually interact with, contribute, and potentially use the project now. You need to know how to use the TypeScript compiler, you need to know how it changes the language, you need to know how to work with types.
And that is the trade-offs that we chose with our sponsor at the start. Now, there are some areas for improvement.
I'm going to talk about some of the stuff we wish we knew at the beginning, and how we tried to fix those mistakes. So as we talked about in our interim presentation, we had a slow start in the beginning, learning all the technologies. Maybe wish we took it more seriously and maybe some study sessions. But that slowed down our estimation, and that was a bit of a problem. We also didn't just commit enough time the first semester and over the winter break that we would have liked to, not quite the 12 hours, which is a bit of a problem. It's been significantly better this semester. We also tried to improve our sponsor meetings this semester by assigning someone to lead it on a rotating manner. And this way someone could focus on making the meetings more, have more of an agenda, less, what do you think we should talk about next? And that showed significant improvement. There's still some room there, but it definitely helped. And finally, we collected all these metrics, and we never really used them to try to improve our process, which, we were pretty happy with the process overall, but, it's a tool we never used. But there are, some things that we thought went well. We thought requirement specification with the customer went pretty well. I think we're all pretty happy with, how that turned out. Our process, we followed it so well so far, and have been generally happy. And there have been no major problems with communication or cooperation, which I know a lot of people say that, but when that breaks down, you start to run into some large problems. And finally, we've been happy with our architecture so far. We haven't run into any major problems or bugs or regressions, things like that. So, that's it. And we're going to talk about what we're going to deliver to our customer.
Yeah, so to finish things off, our project is hosted on GitHub, and with each commit, we kick off a Travis build. Those builds generated output from our tests. As you can see here on the right, those are our graphs. And we wrapped up the project by documenting our code and building a web app to show our library and how our sponsor could integrate it into his existing app. Next, to build on the work we've done, we started to look at a new version of Vega Lite 2.0. It's currently in beta. Once released, there will have to be some work done around integrating it into our library. Live updating is something we support, however, we never take advantage of it, and we'd like to show how this feature could be used to integrate it with an API such as Twitter. We also wrote CSV and SQLite adapters for reading in data, however, we'd also like to add support for more data types. And last, we'd like to support more complex visualizations, such as multi-layered graphs. We currently do not. And to sum things up, we'd like to thank our coach and sponsor. Does anyone have any questions?
Is this kind of representation or structure something I can import to like a website page, or do I need to build an app specifically to use it?
What do you mean this representation or structure? Do you mean the images that we can export for you? Or do you mean the library itself that can let you generate images in real time?
Sort of the library itself in real time.
We have an export format that actually supports exporting a version of the image that is an HTML file that can update in real time. That is only partially completed at the current time, however, and its feature set is limited.
Maybe I'm misunderstanding. So then, how would your end user actually consume this? Is this an application that runs locally to generate these files, or is this?
So we built a library that integrates into an existing application that our sponsor wrote. That runs currently as a native Mac application.
But this would be then extendable because now it's a standard library. You can use other tools that you don't have implementations of this tool for other platforms right now.
Yeah, and as mentioned, as part of our deliverables, we actually have implemented the library running in the browser, which is what our demo was. Sequence of events to create a visualization as you might expect from the application that we produce.
Are there limitations to the sources you can access and use? Do you have sort of an adapter or something?
Yeah, as I said, we do have an adapter framework. We currently have 3 or 4 different adapters implemented at present. Implementing new adapters, the difficulty is obviously scales with how difficult it is to interact with that data source. But generally speaking, it's actually not very difficult.
So what sources are you able to?
At present, we have delivered CSV files, JSON files, SQLite database files, and anything that you can load in memory and process.
How much of this project was based directly off the initial version? Did you kind of port it directly, or was it taking all the features from the initial version and just designing them from scratch?
It was a pretty separate process. Part of the initial requirements phase, we kind of gained a degree of separation. We kind of started from the beginning, just trying to copy the features that already existed.
One of the first things we did was collect a large suite of user stories for what Mark expected his application to do for a user, and we wanted to ensure that our library would support those same use cases.
Less product question, but so you mentioned you had some struggles with time, with putting in enough time in first semester and over winter break. You guys also mentioned that you struggled to track to utilize your metrics correctly.
Yeah.
Did you track like that time data, and was that how you kind of noticed this was an issue, or was it?
Yeah, we also we measure our velocity, and that wasn't great the first semester. There were some low weeks.
Okay.
No other questions? Thank you.
Okay. We are Social Giving, and we're working on the Social Giving product, and I am Ian Parfit.
I'm Zachary Downs.
I'm Yura.
I'm Joe Kaiser.
I'm Jeremiah.
And so in this presentation, what we're going to be going over is we're going to be going over the Social Giving product, what it is, how we built it, the process that we use while building it. We're also going to be going over the bits of technology that we use to design it, some of the challenges that we faced, a little bit about the project history and status, where it's sitting at currently, even some pictures of it that you can see. And finally, we're going to go into our next steps and what we're going to be doing over the summer and some of the lessons that we've learned as a team. So to start us off, I just want to explain what exactly social giving is, because it's important to understand the context of it and the product that we're actually building. So the context that we're building social giving in is that the donor count nationally is declining. What that actually means is donors are people who donate to nonprofits or charities, people who participate in philanthropy. That can be small gifts, $5, it can be large gifts, $10,000, $20,000 or more, but the total number of them is declining. Generally, those people have been baby boomers or older generations, and it should be noted that millennials are not as well represented in this statistic as they should be, and that's a challenge because they should be picking up the slack from where baby boomers are leaving off, and they're not. This problem can be visualized in the following graphic that we have here. At the bottom of the donor pyramid, which is a model used by most nonprofits, you'll see that there are occasional gifts. These are $5 gifts, $10 gifts, something very small. It's not planned. It's generally something someone has extra. Those gifts make up the biggest portion of gifts that nonprofits get. But they're small in size. So as you go up the pyramid, you get to planned gifts, things where you kind of you get someone who's going to donate $10 to $20 to $100,000, and those are less often, but greater in dollar size. So young adult representation at the top of the pyramid, since young adults aren't generally as affluent, is not as it's low, and this is expected. We wouldn't expect young adults who are going to college to donate $10,000 to a charity. But at the bottom of the pyramid where you can donate $5, $10, it's low, and this is unexpected. So the challenge was to create a product, the social giving product, which would actually attract more donors to this base. So that was our challenge, to engage these young adults, make donating and philanthropy fun, and find a way to widen this donor pyramid base. So our sponsor actually came up with gamification of philanthropy, because who doesn't like video games in this day and age? Or hopefully most people do. And gamification has been shown through statistics to attract young adults more than any other demographic currently. So we wanted to build a web app that incorporates stunning and sleek visuals, very modern design. We wanted it to use social media because it can connect to those young adults. They generally have those accounts already. We wanted it to have video game tropes. We'll get into what that actually means later. We wanted it to be focused on philanthropy. It needs to be about donating and not the gamification. The gamification just attracts people to donating. And of course, we wanted people to be able to learn from this too.
All right, so I'm going to go into a bit of our process and the design decisions as to why we chose the process that we did. So we're using Rational Unified Process. For a quick recap as to what that is, there's 4 formally defined stages: the inception, construction, elaboration, and transition. So with the inception, we spent a lot of the time doing requirements gathering. We kind of call it requirements creation, which we'll get into later. But before we could really start anything, we needed to know what we were building. From there, we stepped into the environment setup, some of the documentation set up so that we could just make slight modifications throughout the rest of the semester. And finally stepped into the domain model, which kind of kicked off our next stage. We ended up combining the elaboration and construction into an iterative kind of cycle, which within that there are 4 sub-phases. These phases basically include the requirements gathering, like updating, and a little bit of analysis, discuss it through with the sponsor, and then get into the design and implementation. Because we also wanted to make sure testing was involved, we did allocate an entire week of testing throughout each of our iterations. So given that we have the
the initial stage and the transition stage, we then had 17 weeks throughout the middle of these 2 semesters where we could do the elaboration and construction iteratively. So we have 5 planned releases. Each release is going to be a 3-week cycle, and I'll kind of go into what is part of these 3 weeks. So we have a half week, which is usually Tuesday to Thursday, where we're discussing with the sponsor what we plan on doing, if there's anything he thinks is core for this next release. Otherwise, we just kind of pick up stuff that we could do. For a week and a half, we go into the design and implementation, and finally finish off strong with a week of testing. Last, the final stage is the transition. This is where we're delivering our final release of the product and also any software engineering department deliverables that we have to do. There's 2 other points that are pretty important with our process. The peer review process, so every time somebody does work, they pull out their own branch, do some work. It does need to be peer reviewed by one other person before it could be integrated into master. We're just using master as our final release. There's no other staging. And finally, for risk management, RUP is very strict with how you handle risk management. They have a formally defined phase plan, which we've taken most of the elements out of that and just incorporated it into our project plan. Otherwise, the 4-up chart is very useful, and all of our major milestones, especially for the software engineering department, align perfectly to our releases so that we don't need to worry about mixing up when things are due.
Okay, so I'll just walk through the technologies that we decided to use. So we decided on Python 3 for the back end of the websites. The 2 primary reasons for this were all of the team members were familiar with the language from classes during our time in school here. And secondly, we decided to use the Django framework for the back end. The primary reasons for this is the large selection of libraries available, and because one of those libraries is the admin app, and one of the primary features of the website is to be able to hand it off to our sponsor at the end of the project and have him be able to create objects without going into the code. So we use MySQL for the database management system. This is pretty simple. It integrates easily with Django, and it scales up to enterprise when that time comes. So for the payment system, we had to accept payments for this website in order to handle donations. And in order to be PCI compliant, which is basically a set of rules for handling credit card information, we had to either use the Stripe library or something similar, or implement our own handling of that. So Stripe is widely used, and it's reliable. And these are 3 tools that we used during our project. We used Slack for team communication. We used Trello for tracking tasks and bugs, and we used Google Drive for documents and collaboration.
So I'm going to go over the requirements that we had for our project. So when our sponsor first came to us with this project, wasn't really anything comparable on the market, so we had no idea exactly what to expect from it. So our sponsor came to us with a lot of goals, business-wise, and a lot of user stories, but not really too many requirements on the technical side of things. So we had to do a lot of requirements. We had to move away from requirements elicitation and move to requirements creation. And we were a bit, stumbled when making this process, making this change, because we weren't really used to creating our own requirements. We were used to, asking somebody else what the project needs and what needs to be done. But it was a slight learning curve, but we decided that the best approach would be to brainstorm some ideas that we had for the project, to see, make a survey that we sent out to see exactly what other people would consider would be a good idea for the project. And after we got all those figured out, we just solidified all that stuff in our project plan. So the core features that we decided to go with for our project was, since our project is based upon philanthropy, we would decide that we needed to make sure that our application had the ability to donate to nonprofits in itself. We also felt as if that another good idea, or from our sponsor, would be to make sure that we could share any sort of like progress that we do on the application to social media sites such as Facebook, Twitter, etc. And we came up with a few different ideas to gamify our the web application itself. And this included, making themes for each of the nonprofits, which are just sort of kind of like categories for the nonprofits. With those themes, what we would do is we would have competitions that would sort of pit those different categories together to see who could, raise the most money or, get the most points. Finally, another idea that we had was a day of giving, which our day of giving is similar to RIT Roar Day, where we just have one nonprofit sort of kind of be at the forefront of the site, and donors would come to the site and donate to that specific nonprofit, and during that whole day, the nonprofit will try to raise as much money as it could. In terms of our scope for the project, our sponsor, when we were talking about the requirements for the project, our sponsor did not really want us to put too many ideas out of scope, because they didn't want to discourage us from getting certain aspects of the application completed, not completed. But he did understand that we were under a time constraint, so we would not be able to get to a lot of the features that we initially had planned out. But one of the things that we definitely realized we would not have time for was mobile implementation. So creating a mobile API, with only having 2 semesters to really work on the assignment, we wouldn't really have a chance to get to it, but we did feel the need to make it so that the application could be easily integrated into a mobile API should this project be picked up and continue forward.
So now I'm going to go over a little bit of our architecture. I'm not going to scroll through the massive UML we ended up with, but we did break it down into a couple different subsystems, which is actually how our code is set up as well. Each of these subsystems includes a variety of different models and the interactions between them. There are slight interactions between the subsystems, but generally a lot of the core functionality will exist within one or two. So we did end up choosing Django, as we discussed earlier, and that very heavily defined what our architecture would be. Django is extremely opinionated, so we did just kind of follow along with the model view template that they kind of set up for you. It would have been a little too much effort to try and rewrite how Django was doing stuff when it did a lot of the stuff we already wanted. Also, as Jeremiah mentioned, our sponsor did want mobile support in the future, so we made sure that with Django REST framework, you could just plug in a couple serializers and it's basically a working API for any mobile client to then pick up and work immediately. Here's a really quick example or diagram of the information flow through Django, coming from the browser, working its way through the system, gathering the information, and finally working back up to the templates as the MBT does.
So I'm going to take you through probably the most key process that we have in our product, and that's donating. It's the core functionality. And in this example, what we're going to be walking through is an anonymous user who really likes the Red Cross for whatever reason, and they want to donate to that. And it's going to show you how gamification comes in and actually incites this user to use our website rather than going to some other website or going to the Red Cross directly. So in the first bullet up here, we have that an anonymous user likes the Red Cross. So on our website, they find the Red Cross, they found the page, and they click donate, and then they enter their credit card information onto the page. From there, the credit card payment is processed, and a donation object is recorded into our system, and we keep track of any information that the user put in, as long as it's available, the nonprofit that we donated to, and we keep track of the time that the donation was taken and how much money was actually donated. This is because nonprofits really like this information, and if we can give it to them so they can track statistics of who's donating, they want that. And we do have a report subsystem which is built with this. Then a gold reward is calculated based off of this, and gold is the gamification aspect. So if, say, they donated $75, they might get 7,500 gold in our system, and I'll explain what that is in a second. But then they're invited to actually sign up. So when they sign up, we wanted to make this easy. So they can either sign up through the social giving website, or they can do a one-click sign-in through OAuth with Facebook, Google+, or Twitter. And again, most of these people who would be using this website would theoretically already have these accounts, and that should make it fairly straightforward to actually use our service.
So then, once they've actually signed up, they see a big splash and they get a donation bonus. They have that gold in their account. So what that is gold is an in-universe currency. It's kind of, if anyone has played Xbox or used a Nintendo or a PS4, any of those systems, they use in-universe currency that maps to real-world currency. So this in-universe currency with gold actually translates back to real dollars that they can donate to nonprofits. So if they donated $75, they might get 7,500 points, which translates to $7.50 per se. Those aren't the actual rates, but for an example. So that $7.50, then they have sitting in their account, they can say, hey, I want to donate that off to cleanwater.org. And that's basically free money, incites them to use our website instead.
Okay, now I'll tell you about our project history and current status. So in the beginning, we spent a couple weeks brainstorming and coming up with requirements. And since then, we've been implementing some of the core functionalities such as donating, donor accounts, and some of the reporting for nonprofits. We started working on the UI a little bit, but that's still a work in progress. We also have a testing framework set up using Selenium and PyTest for our unit tests. So these are the metrics that we're collecting for the SE department over on the weekly basis. The first is cyclomatic complexity, and that's a measure of how complex our code is. We also measure the number of open bugs and the number of open tasks. We also have a test coverage metric that tells us how much of our code is covered by our unit tests. So here are the values that we've collected over the past few weeks. As you can see, the cyclomatic complexity is high, which is a good thing. So that means that 98.5% of our code passes a certain benchmark that we set for ourselves. We currently have 3 open bugs, and we try to keep that at a minimum at all times. We have 26 open tasks right now because we're in the middle of a development cycle. And our test coverage is at 63%, which is kind of low, and we're going to work on that as time goes on. And this is an example of our UI. So as you can see our logo on the top left, and then you can see some of the most important links on the top right. There's some social sharing buttons on the left side, and you can also log in using all the different OAuth methods, as well as your own social giving account, if you choose to sign up that way. And this is the sign up page. Again, you have all the navigations linked at the top, and then you can also see the different OAuth methods, or you can sign up with an SG account again. And then you can also see the progress bar at the top right of the card, where you know how far in the sign-up process you are. And this is an example of our home page. So basically, here you can see on the right side, assuming you're logged in, you'll see your account information. So you have your avatar, username, and the amount of gold you have, as well as some other metrics. On the bottom right side, you can see some of the events that are currently going on and that will go on in the future. In the left side, you see the main competition. So right now, there's a competition for the animal theme versus the water theme. And you can see the progress of who's winning right now.
So far in this semester working on this project, we've come across a few challenges and just a few things that we felt were beneficial to our project. So one of the things that we realized that especially during the requirements creation phase, we needed to definitely work a lot with our sponsor. So anytime we had an idea of what we felt, could be a part of the project, we, submit the idea to him, and he, either give us the thumbs up or, work with us to try to, better fit the mold of what he has envisioned for the project. This definitely came in useful. This definitely was a lot more helpful than we originally anticipated, due to the fact that, we really had little idea what we were doing to the project at first, but as we came along and worked with our sponsor and worked with the requirements, we started to get an idea for what he actually wanted, and made it, moving on and integrating a lot of other different qualities a lot much simpler. We also realized very early on that unit testing would be a little bit problematic. So what we decided to do was to designate two members of the development team to start unit testing and get as early as a head start on unit testing as possible. That way we did not fall too far behind when it came to the testing phase. Another really good idea that we felt we should do was between iterations of our development, we would give the developers a 2 or 3 day break. We wanted to relinquish the stress that we would put on our developers due to us all being students, all having other classes and assignments, and we wanted to make sure that we all had enough time to catch up on developments that we fell behind in, as well as to get an early start on the next iteration of the development.
And as for our next steps, we're going to obviously continue implementing our functionality. We also plan on hitting some of the out-of-scope functionality if we have extra time at the end. We'd also like to improve our UI a little bit based on some new design ideas. And our project sponsors already decided to have a second iteration of senior projects, so we're going to start preparing documentation for that probably a couple weeks before the end.
And lastly, some big takeaways that we had just while we were working on this. We definitely spent too much time on documentation at the beginning. This was a web app and we needed to be a little more agile with our process, so we're trying to move towards that as we go forward. We needed to nail down the core functionality. We did that. We put it in our project plan, but it wasn't something we had within the first few weeks because this was a brand new project. And also a big step that we're going to be taking forward looking into the summer is going over our UI extensively. We didn't focus on it enough at the beginning, and now we realize that was one of our key features that we needed to have in this project, and so we're going to try to focus on that a lot as we move forward.
Any questions? Top left was up immediate.
So, you guys are specifically focused on millennials building. Have you given any looks into the marathon events that I'm familiar with, the Days of the Quick Marathon? I think there's another one that's actually coming up this weekend called Urban Winnipeg. There's sort of, I think every year they've been increasing the amount they get for the charities they do, and they actually offer gamification for all of their incentives. Basically, the idea is that the speedrunning event, people speedrun games, and people can donate for different incentives within those games, seeing things they wouldn't normally see, or changing the way the run works. Have you looked into any of those, or looked into highlighting those types of events?
Yeah, so I'm actually very familiar with AGDQ, so it's Awesome Games Done Quick is what it's called, and it can be during the summer or the winter. We definitely want to incorporate some of the processes there. I don't know if you noticed on the main page that we have, there's a bar that's showing in the lower right-hand corner. I'll try to go back to the slide. So here, you can see this bar. It doesn't have the best UI at this point. That's something we're focusing on over the summer. But those are two themes. Those themes are a bunch of nonprofits that are in the same particular area. And one of the core concepts of this is that you can donate to one or the other to kind of get them to beat the other team of nonprofits or the theme. And that nonprofit group will actually get a benefit from winning, essentially. Everyone is going to win in this, but our sponsor and we really wanted to take the focus really off the gamification and put it more on the philanthropy, because there's no product out there that's currently really doing that. There's also websites like freerice.com, and that's really focused on the gamification aspect, just like AGDQ, and this was supposed to be more focused on the philanthropy side of things, with the gamification as a way to just incite users to come back.
There's 20 names, so.
Sure. So you mentioned that you can earn this gold, your in-universe currency you're calling it, from donating money to different charities. Where does that gold come from? Where does the credit, because I can then use that to donate to people, so that money has to come from somewhere.
So there's a couple different sources. So one option is that you actually buy gold and don't immediately donate somewhere. So I can either go to Red Cross and immediately send $50 that way, or I can go to Social Giving, buy $50 worth of gold, and divvy that up to a couple different places, eliminating some of those like administration fees and stuff like that. And whenever you donate to somebody, a percentage of that, also we're calculating like how popular that nonprofit is, you get a percentage of the donation back as extra gold that could then be sent to another different nonprofit. Another option is a learning event. So if a nonprofit hosts a quiz on like how to recycle properly, you could earn some gold that way, and that would be donated to different nonprofits, things like that.
Sure. So when in the example where I donate money and I get some percent back as credit, when I now try and spend that on another nonprofit, where does the actual money that's being given to that nonprofit come from?
So, because that's also, Social Giving is also a nonprofit and a corporation that are working hand in hand. So that money is coming from basically our sponsor's company.
Okay.
So how are you accepting the proceeds? And I'm wondering, is it the nonprofits that register to your site, host the event, and then they verify that you paid them? Or are you working in partnership with their kind of payment services and kind of validating?
Yeah, there's a lot of complicated stuff going into that. So depending on what, it's not formally laid out yet, but social giving would be handling how does a nonprofit like register with social giving. And there may be different stages as to what they sign up for. Some of it will be they get hosted in a theme competition once every 3 months. Or they might get to host 20 learning events throughout the year. Like there's different things that they could sign up for.
So then I pay social giving.
The nonprofit pays to get on social giving, and then also all the donations that are targeted toward that nonprofit go directly to the nonprofit, minus like the 3% plus 30 cents or whatever like PayPal might take out.
Okay,
Stuff like
so
that.
you'll be accepting payments for PayPal like through your website?
Yep. Yeah, we do have
Stripe.
that implemented. Stripe handles it, yeah.
Yeah.
So you noted that you're planning on improving your user interfaces and doing additional gamification things. Have you guys given any thought to usability testing that you might do to work on that?
So I think, since I'm kind of taking the UI on now, I think the issue that we kind of pointed out with the UI is that we didn't think of the UI beforehand. So not only do we not, we don't really have something that is usability testing ready yet. We're still in the process, the 3 images you saw are the only pages basically that are properly usable at this point. The rest of it is still, all the functionality is there, but there's nothing clean about it. There's no accessibility or usability thought into any of it. So that's the stuff we need to build before we can really test it.
And also, that's in our project plan. We've actually up to this point been very good about sticking to what our milestones are. And that's part of the RUP phase plan risk assessment portion that they have. So you build in other tasks like usability testing along with your major releases, and that way you can kind of get a combined look at what you're going to be doing at that point. And that's one of the things that our team has actually done really well is stick to that milestone plan. And we do have usability testing starting basically right after this current release that we're in. So this release is to push for a lot of big UI aspects and then start gathering user feedback, but we needed to get to that point first.
Thank you.
Yeah.
I'm curious as to how your requirements phase kind of went. Did you do any research into successful social media campaigns that some charities have done? And if not, what kind of drove that process?
I couldn't hear it. What?
So I'm just wondering how, what drove your requirements phase? Did you do any research into successful social media campaigns from some charities and what they did, or what exactly drove your requirements? I guess what I'm asking.
Okay, so I think actually a lot of it came from our sponsor. Our sponsor knows a lot about the nonprofit world. Some of it also came from the user surveys that we conducted. And if you're saying looking at what other people have done, my wife actually works for a nonprofit directly, so I get to see the ins and outs of that a lot. So I was, in particular, kind of an inside look into different campaigns and how they work, what might work on social media, what might not. And so there's been a wide source of information surrounding that. But yes, we did do the research on that.
There's also a lot of, somebody had happened upon the rice donating app, things like that we just kind of checked out when it came up to us, or other people had mentioned it to us, things like that. But that helped, was just seeing other examples of it.
Let's thank the team.
Good. All right. Hello, we're Avalanche, and our project is Recruiter. I'm Zane Grasso.
I'm Max.
I'm David.
And I'm John.
All right. So our problem we're trying to solve for this project is the ability for students to connect with recruiters and job openings. The end goal for the application is for our users to end up with an interview both for the students and the recruiter. So we have three main users: the student, who want to find open jobs and thus interviews; recruiter, who are looking for qualified students, but they don't want to hassle with thousands and thousands of resumes; and then we have an admin who is meant to facilitate the application as a whole. So we were tasked to design a mobile application and implement a mobile application that supports both iOS and Android. When we first received the project description, the title was Tinder Meets Career Services. And we're similar to Tinder, where we match a student's set of skills with a certain job's skills that are associated with it. The mobile application is meant to improve the process in which recruitment happens, and we do this by phases. So in order to get to the interview phase, you must complete 2 phases prior to that. We have the problem phase, which is an opportunity for the employer to maybe put out a problem statement for not the student to solve, but to maybe show how their experiences will contribute to that certain job posting. And then after that, if they make it past that phase, we have the presentation phase. And this is an opportunity where the student gets to see what the company is all about, either through a video or a certain other type of presentation, and then where the student actually makes their own presentation to actually sell themselves to that company. This is for career services offices, and they will be monitoring statistics like major, year, GPA, stuff like that, who's using the application. As far as the requirements, at the beginning of the project, there was non-defined requirements, so it took us a while to understand what the sponsor wanted, what we understood. So the first couple of weeks were just us and the sponsor getting on the same page of what was expected and what was needed. So we did the basic record and discuss. We come back with our requirements document, and we'd get that approved. We'd get feedback from him, and then go back to the drawing board and create more requirements per his needs. And we did this until both us and the sponsor were on the same page.
All right, so once we had a good basis of requirements that both we and the sponsor agreed to, we moved on to the design. So with the design creation, the application itself is fairly simple, as you'll see in just a minute, and we just took the top-down approach. So we took actions that users would be doing with the application, determining what the mobile application would require to satisfy those actions, and then what the server would require in order to serve data and interact with the client so that they can complete those actions. From there, we moved on to the server, and we focused mostly on this in terms of architecture, saying as how the client is a more simple design than the server itself. And then our server, as you'll see in a minute, is split up into HTTP endpoints. We're using a basic REST API for updating and serving data. And then there's models in a database that interacts with. So here you can see our server architecture. So on the right there, you see our HTTP API. And in this, there's a whole bunch of modules. Each module is constructed, as you can see on the bottom left here, of both a controller and a model. So there could be a couple of different models in each controller. So for things like a schedule, you might have a schedule model, but you also might have a time slot model that fits within that schedule model, and then the controller. The controllers are used for sending the data to the client and also manipulating the data when updates come in from the client or to create new data. And then on the top left there, you can see we have services. Services are just server code that is invoked by the various HTTP controllers for manipulating data within the database. So things like matching, like actually looking at the set of skills that a user has and looking at the set of skills that a job posting has, and then analyzing to see if there's a match, is something that's included in our services. And then here, our client architecture is pretty much the definition of a model view controller, where the view is obviously the screen and scenes that users are seeing on their devices. The controller controls how that is being displayed, what is there, and then mostly communication. So that's what the controller is heavily responsible for, is the communication between the client and the server. And in this case, the model representation is truly just the data that the client receives from the server when it makes those REST API calls.
Our implementation strategy was the evolutionary prototyping methodology. We develop a prototype, show it to the sponsor, get feedback on it, develop it a little further, show it to the sponsor, get feedback on it, etc. We felt that getting feedback from the sponsor was very important. As Max mentioned, I think it was Max, the initial requirements we were given weren't super concrete, so I spent a lot of time figuring it out and deferring them with the sponsor. We assigned story points to our tasks based on planning poker, which ended up working pretty well for us. We mostly assigned tasks based on who would volunteer for them. However, when we first started writing the code, we were using Xamarin for the mobile apps, and we were using it poorly, so we had like separate code for the Android and iOS UIs. The people with MacBooks had to develop the iOS code because you need iOS or you need a MacBook to build iOS apps. We have since switched to using Xamarin Forms. That requirement is no longer in place. Our testing, we have unit tests for the server, some of the server code. We don't have any automated tests for the UI or any automated integration testing. We've been focusing on delivering features over delivering tests. They haven't been a priority for us yet. The current state of the project, you can register as either a student or a recruiter. If you're a recruiter and your company doesn't exist in the system yet, you can register a new company. You can log in as either a student or a recruiter. It's the same login page for both. The system will determine which type of user you are automatically and give you the correct flow. As a user, you can edit the skills that you have, and those skills are used to match you with job postings. As a recruiter, you can create job postings, which are then matched with students who have relevant skills.
We're going to show you our application, where we're at.
As you can see here, we're dual wielding emulators. We've got an iOS one and an Android one running at the same time to show you both the flows. All right, so we're going to go ahead and register both users. Student.
So starting off with the student, you can see it's pretty basic form. Just basic information, name, email, password, etc. The important part of this form is towards the bottom, where the user mentions what their preferred location for a job might be, and then what their preferred company size is. So if a user requires East Coast or West Coast, or whether the user prefers a large company or a startup company, they can specify that, and that's taken into consideration then when matching users to the job postings that recruiters create. Just finishing up the form here, you can see we have some ongoing validation to ensure that the information the user is inputting is correct. Finish registration here, and we're thrown back to the login page where we get a registration success message, and go ahead and log in.
All right. Looking at skills.
Adding skills, we have a list in the database of all the skills that are available, and this down the list of those skills, and that's what you see copy off when he types in to the skills box.
Right now we only have a few skills in the database, so these are all that show up, but we could add a huge list of skills if we had those skills. So we can save those skills, refresh the page, and there's already a job posting in the database, so you see we match to a job posting. Right now we're going to register as a recruiter and create a job posting. So recruiter registration is kind of similar, where just the fields are different. So if I enter a company name that doesn't exist into our database, tell me I could go and create, it's another form, but I could go and register a new company. So I'll say no and just use one that's in our a company name that's in our database.
And then it'll look at the database, find the company with that email suffix that we gave it, and fill it into the company name field you see up there.
Mm-hmm. So automatically filled in United States, that's the company that I'm working for. And then I can register. Log in as that user. Now we can create a job posting.
All right, so this job posting form, again, it's very similar to the registration forms. Some basic information, position name, position description, et cetera, et cetera. Those two forms, the one form at the bottom for the location is what will be used to match and compare against students and what their preferred locations was. The other big thing here is skills. So we have both recommended and required skills for the job posting. So required skills are skills that have to exist within the student's set of skills in order for a match to even be considered. And then recommended skills are skills that if the student has, can provide a better match. And so students that meet both the required skills and more of the recommended skills will be matched first instead of students that don't have all the qualifications. And then you can see there you can actually select the weight for how much you want the recommended skills to matter. And here we're entering a problem statement. That's used later in the problem phase. And then there's a presentation already associated with the company that the recruiter works for that will then be used for the presentation phase later on.
Talk about we also have a phase timeout for each phase. So we have a timer on each phase, so if it takes too long for a student to respond, then they're automatically kind of kicked out from that job posting. All right, we can resize this. Just,
all right, so we can see now on the right there's a new job posting that the recruiter just added. Back, and if we refresh the students list of job postings, they're now matched with that new job posting because they match the requirements.
That's what we have so far.
And so we're going to be working on next, we actually want to get through making those problem phases. So after the student has matched with a company and decided that I want to work for this company in this position, they get a series of phases where they get to know the company better, the company gets to know them, they get to make sure they're a fit for the job, and then later get an interview. And those are the problem presentation and interview phase. We also want to input profile editing so that the student can have their resume on file so that once they get to the interview, the company can then get their resume to use while arranging the interview. And then we talked earlier about the third user type, the administrator. We want to be able to give them a dashboard that they can view from their home computer. So we're going to be building an additional website for that so that they can go to that website and view statistics as well as go and approve companies. Right now we're just automatically letting any company and recruiter sign up, but once we add security features, companies are going to need to be approved by the administrator so that they can actually post jobs, because we don't want any person coming in applying for asking for students to apply to their job. And then also we want the employer dashboard, which is going to be where the employer navigates to their job posting and sees a list of all the students that can apply so that they can go through, if they have a large number of applicants, they can go through and see what action is needed from them. And in terms of so far for our metrics, we've got defects per 1,000 lines of code, test code coverage, percent test pass, and cyclomatic complexity. In terms of our defects, we've actually been doing a pretty good job of keeping our number of bugs down. We're just tracking the bugs in Team Foundation Server whenever one of them comes up. Test code coverage, we only have unit tests for our more complicated server-side features, such as matching, because the business logic behind
what we're doing so far in the is more or less pretty like just getters and setters aside from the matching service. Percent of tests pass is obviously 100%, and cyclomatic complexity is low for the same reason I mentioned in terms of the test code. However, in terms of form validation, it can get kind of high. As for our process metrics, we really just have the time and effort tracking and our slippage. We have our time effort tracking chart up there with our estimated and actual times for the entire team. As you can see, as we neared the end of our requirements gathering in weeks 6 through 8, we kind of hit a point where we were thrashing a little bit and trying to figure out where we were going to go next. After we hammered down our latest prototype and our UI mock-up there, we ended up getting to co-design and coding, which is where you see our estimated and actual time go way up. As for slippage, our iteration 1 of our code development went kind of badly, and we ended up delivering with very little UI to show to our sponsor. So we had to move those over to iteration 2 and switch our UI implementation so that we could get that worked out. So it worked. Our top-down co-design, where we developed a mock-up prototype and then built that into individual features, worked out really well for us. And our architecture process, which it revolved around us breaking that into models and then developing endpoints from those models that we would then bring into use for our client side, worked out really well for us. Our estimation through planning poker ended up being pretty accurate, despite the fact that our estimations for iteration 1 coding didn't go too well. The overall time per story point ended up being more or less on point. And also our code review and pair programming systems kept a lot of features on track in terms of if anybody had a problem, they would meet together and get everything worked out before committing broken code. In terms of what didn't work, you saw earlier the requirements gathering. That lasted a few weeks longer than it really should have, and we sort of nailed down what our prototype was going to look like before then. Writing the native Xamarin apps didn't work out very well for us, so we switched to Xamarin Forms. We really didn't have any experience writing native code for mobile applications, so we had a hard time with that. As well as updating our scheduling information, we weren't really on track with counting how much time it took us for each story point in the first iteration. So as we go through the further iterations, we're going to be needing to keep better track of that, and that kind of also pairs into committing to too much, where we really took on too much. We were like, 18 hours over the next 2 weeks, take 18 story points. Story point ends up being more than 18 or more than 1 hour of work, so we were kind of swamped for those 2 weeks.
As far as the improvements we are making to our process, is we're going to update documents more frequently, keep track of actual time spent on tasks, like John just mentioned. We didn't really have an idea on how many or how long each story point would last or would take us, so we have a better idea of what our velocity would be for each iteration. And as far as demonstrating to our sponsor, to be able to do this more frequently and easier now, just because we went from documentation, we actually used Mockingbot, which is a web app that you can kind of design your own mobile application on there and just create a flow of the application if you needed to. And then we actually have a working prototype now that we can show our sponsor. Are there any questions? That is our app.
So I know you said you tried doing the native Xamarin.
Yeah.
Did you discuss with your sponsor and do you think about the trade-off of switching to Xamarin Forms, given that it's intended for rapid prototyping, so you're not going to really be able to get all the features of the native UI and the real native feel of the application?
As far as that goes, our only requirement really was to have two applications, one for Android and one for iOS. We did some research beforehand, before committing to the switch, to see if there was anything natively that was going to be necessary. There's not really, it's not an incredibly difficult app in terms of unique user actions. Everything is fairly standard and fairly similar to what Xamarin Forms supports. So we just made that decision to move over there. In the end, it worked out really well. It took us about 2 to 3 days to recreate what took us almost a week and a half in the native applications using the Xamarin Forms.
Did you consider the usability and the design feel of the app? Does your sponsor?
Yeah, we know that there's going to be some fine-tuning between the two separate applications, so between Android and iOS. Luckily, Xamarin Forms still supports adding native code on a necessary basis for tuning what the application might look like on Android as opposed to iOS, and then matching those styles.
I know that you said that there wasn't so much a test on, or a focus on testing, rather than a focus on delivering features. Is there any particular reason that you decided to make that trade-off rather than scaling back some of the features and testing them more thoroughly?
Like we said, we kind of had a late start with the amount of requirements gathering we had to do the first halfway through the semester, so we didn't start implementation until maybe week 11. So we wanted to get a product out there, especially for the interim presentation. A lot of our client-side code is mostly UI, so again, we didn't do any UI testing besides manual testing, but we feel that we covered a lot of the important server-side code with the code unit testing that we have now. That was kind of the reason why we chose.
So you said that you only have 2 Macs with which you can actually work on iOS development. So I want to know what kind of thought have you given to this as a risk? How would you handle it in case one of you guys hit with a bus? There's no Mac.
Yeah. So yeah, it was definitely a risk. When we originally started, we actually only had one person with a MacBook, and then somebody got a MacBook so that they could do that development. In terms of risks, it's not as risky anymore because Xamarin Forms, one of the people who can't develop for iOS can develop for Android, and then it's already created on iOS. Really the only thing to do is review it and test it and ensure that it also works on iOS. So with that, there's a lot less overhead in terms of what is specifically necessary to have a MacBook for with Xamarin Forms. So that was one of the big benefits of that too.
So one question our team was asked when we did our poster demonstration was, what differentiates your product from other existing products that already do this? You're basically a job posting site, which there are tons and tons of. So I was curious if you have kind of a good answer to that, of what is your differentiator, what makes it worth using yours over ZipRecruiter or any of the other postings?
Well, the idea was that instead of just sending out your resume to a million places, you could get a better idea of what a certain person is like without having to go into, like, actually make the interview process. So there was a lot less commitment on the recruiter's side to go through a lot more students and get a better idea of how they work and how they fit the position before they have to go through the full interview process.
Are you concerned, though, that it puts a lot of impetus on the student to now build this whole, you mentioned the whole presentation stage. That's a lot of extra work for me if I'm looking at 15 different jobs I'm trying to apply to.
Yeah, well, the idea was that the student's we're going to have to put in a bit more work, but with the added reward of if you do put in the work, you have a much higher chance of getting an interview with the few places that you apply to.
And the matches that you do get will be better fits because you'll already know something about the problem you might be solving, or you might already know something about the culture of the company, things like that.
Thank you.
Let's thank the team.
My name is Kelly Trainer.
I'm Danny Fehrenbach.
I'm David Keslock.
I'm Dawei Liu.
And I'm Michael Shook.
And our project is Cybersecure Data Paths for Internet of Things Mobile Medical Devices. Our sponsor is Fast Forward Recovery, and our coach is Professor Timothy Witcher.
So without further ado, here's what we're going to be going over. We're going to be going over the project background, the domain of BSN, Body Sensor Networks, our process and methodology, our secure architecture, which is made to accomplish our project goals, our design decisions that adhere to those goals, and what we did well and what we didn't, and what we plan to do moving forwards. So first up, our sponsor is Fast Forward Recovery LLC, and they want a body sensor network for a physical therapy application. But they want all the information that travels within that within that body sensor network to be completely secure. And that's where we come in. We were tasked with researching all of the means and modes to make such a connection completely secure, or as best as we can.
So the motivation for us to conduct this research project is the recent uptake of connected medical devices such as insulin pumps or pacemakers with wireless capability. So if a malicious attack were successful on a insulin pump with connection, it could command the insulin pump to inject a lethal dose of insulin to the patient that threatens the patient's life. And so the rapidly growing market for IoT, Internet of Things medical devices expose some problems with wireless communication technology. One major problem is the challenge in maintaining the security and privacy of the patient health information throughout the data path. And because these IoT devices are medical devices, so they must comply with additional Food and Drug Administration and Department of Health and Human Services regulations, especially for electronic health record. Before we can come up with a solution for the problem, we'd first like to familiarize with the application domain. Is the body sensor network. General overview is this BSN is a common architectural pattern for medical devices or IoT medical devices, and usually consists of one or more body sensors mounted on a patient or a user, and they'll gather patient or user's health data and wirelessly transmit that to a data gateway. The data gateway could be a phone or a desktop or anything for a health provider to review and analyze the user's health data. The data gateway can also aggregate the health information of the patient or user to a server. Understanding that application domain, we applied that specifically to our project. We came up with this domain model that addresses the key actors in the system. So there is the physical therapist who will use an Android phone with a custom Android application that pulls a patient device that's mounted on a patient's back, so the patient device can monitor the patient's posture. Those patients are usually recovering from a stroke. And the patient device has internal gyroscope sensor, and the patient device also has a physical data storage to cache the gyroscope data if the connection between the patient device and the Android phone gets lost. But in normal operation, the patient device would return the gyroscope data to the Android phone, and the Android phone would display the data and provide visual aid to the physical therapist to analyze the patient's posture, and the Android phone would also aggregate that health information to a cloud database for persistent storage. In working with our sponsor, we defined the scope for the project. So that encompasses designing a architecture for secure transmission of patient health information over a BLE, Bluetooth Low Energy Protocol. And using that architecture, we need to develop some prototype software to prove it's secure enough. And once we have the prototypes ready, we like to assess the security performance of our architecture by performing attacks such as denial of service, replay attack, or in-the-middle attacks that's commonly known for BLE devices. And along the way, we'll assemble all those findings into a research paper, and it's a potential for publication in the future.
So because the scope and domain of our project is so diverse, both the team and the sponsor agreed that it would be best to work with an agile Scrum methodology. The weekly meetings with our coach and sponsor lined up very well with our sprints, and we found that with a research-focused project with focus changes and hard-to-predict research findings, an agile-based methodology works best. So for requirements, the paper had a requirement of researching BLE connections in the context of mobile medical applications, and the research also was intended to research BLE attack patterns on those connections. The prototype was designed to communicate with an Android application and a patient device over a BLE network, and it needs to send data securely using encryption, which will be talked about in another slide. Well, our team had several risks over the course of the semester. Those included switching focus between the research paper and the prototype. Sometimes during a sprint, it was hard to decide which deliverable would be the most productive to work on. We also encountered a risk of learning new tools and technologies. Sometimes the time allotted for the sprint, it would take too long to learn these new technologies, and we had to put that on the back burner. Another risk that we had was switching technologies halfway through development, and this will be later talked about during implementation. We had two metrics that our team tracked over the course of the semester. Effort tracking was tracked through tracking the hours that individual team members worked on during sprints, and and story points were also tracked by assigning points through planning poker. And as you can see, the effort tracking is on the right, and the story point tracking is on the left.
So, in order to define some of the requirements for our eventual prototype, we decided to create a threat model of what data is being transferred throughout each part of the system. Essentially, there's two main components, which would be the patient device on the left and the therapist device on the right, both of which contain Bluetooth Low Energy transmitters as well as data storage for the motion sensor data that's being passed in through the patient. The main focus here is motion data is being sent one way from the patient device to the therapist device, but encryption keys as well as session information is being passed in two directions. In addition, there is a requirement to connect our application to an electronic health record. We don't have to focus on the security of the record itself. That's out of scope for this project. However, we do have to concern with the data being transmitted from our application outward. So we had from there a few major security considerations, most of which are derived from different federal standards. Our primary concern is patient confidentiality, in that we are transmitting health-related data. It's the gyroscopic sensor data that is going to be attached to our patients. That has to be protected. Secondarily, we have the integrity of our protocol such that an attacker can't spoof data, send messages that are not intended and have them be accepted as valid. We plan on achieving that through different methods of authentication and authorization. And then finally, and probably the least of the concerns, is the availability of our protocol. For example, a denial of service attack to prevent the sensor from functioning. So our main goals for the prototype are to mitigate the extant vulnerabilities in Bluetooth Low Energy. Mainly, there are security protocols built into the transmission standard, but they have been thoroughly broken with several sample attacks, which we'll be getting into in a couple of minutes. We plan on doing this by pre-encrypting all of the health data that is being sent between the devices, encrypting the device storage such that we can save hours of sensor data safely, and then preventing the known attacks, which we will be testing in the next phase of the project. So our main requirements include the addition of AES GCM encryption to all of our transmissions. This is sort of split into two pieces. AES is the Advanced Encryption Standard, which is the current government recommendation for all of the over-the-air and on-device transmissions. Then Galois counter mode is an operation on top of that, which provides us with variable length transmissions as well as authentication on the transmissions, both of which can be used to help defend against some of the attacks. In order to achieve this, we are planning on using elliptic curve cryptography to connect the two devices safely, since they have to be connected over the insecure channel with BLE. Each session will have unique data to prevent certain replay attacks from occurring, and encryption keys will be recycled every 30 days. The generation of the keys takes a little bit of time, so having the keys stored on the device is a good idea, but for usability reasons. Recycling them every 30 days will help prevent certain attacks from occurring. And then we plan to test out the architecture using Gitacker, which Daniel will get into right now.
So before we get into that, we have a couple of restrictions within our testing strategy for our secure architecture. Number one, we cannot physically interact with the patient, nor can we physically interact with the physical therapist. We can't just walk up and stab them. That kind of ruins the point of our project. Number two, we cannot physically interact with either of the devices. So we can't actually go up and touch and like hardwire an attack right onto a device. We have to do it remotely. Okay, so getting into it, we want to protect against, we're going to be using a tool called Gitac, which we're running, which is a node library that we're going to be running through Linux, and we're going to be testing 5 main attacks. 2 of those attacks don't require man-in-the-middle connection, and 3 of them do. So the 2 that don't are passive listening and denial of service. And passive listening is just reading any of the advertisement data that's coming from the patient device, which is just saying, oh, here I am, please connect to me. Denial of service is an attack that will take advantage of the connection limits that either device can have, and sometimes the processes that each device goes through to connect to the other one. Then the man-in-the-middle attacks require Gitac, which will spoof both the devices at the same time and provide a connection between the two of the patient and the physical therapist device. And one of these attacks is called active listening, which just takes the pair of devices and looks at the information going back and forth, sometimes records it, but all it's doing is looking, no touch. The next attack, we're actually going to be touching this data. We're going to be either injecting commands or spoofing data that ruins the integrity of the data that is going through. And finally, we're going to be looking into replay attacks, which essentially is just the man-in-the-middle recording a interaction going between the devices and then replaying it at a later time to, even if the interaction was completely encrypted, replaying it and performing an unwanted operation on the device.
So regarding the implementation of our prototypes, we made some decisions in terms of the technologies that we used. Initially for the therapist application, we were using MIT's App Inventor, which allows you to create Android applications from a web-based interface, but we found it to be too restrictive in terms of the encryption libraries that were available. So we switched to React Native, which is written in JavaScript, and the peripheral device, which is on the patient, runs Node, which is also JavaScript, and both applications use OpenSSL, specifically the AES encryption and ECDH key transfer algorithms. So you can see the tasks that we've completed have the check marks. We've designed the secure architecture. We have drafted a proposal of that architecture, and we have completed the first two bullets of the prototype, namely the encryption and key transfer. So what went well? Our team had effective communication during meetings. We were able to complete the drafted research paper, which we were proud of. Our velocity remained constant pretty much throughout the entirety of the semester, and we became more efficient during our meetings. So we had a fixed number of meetings per week, but we were able to accomplish more during each of them. Some challenges that we faced, we identified a number of risks at the start, but we didn't periodically update those. So some unforeseen risks came up during the course of the semester. Additionally, applying Scrum to research can be difficult because research tasks aren't the same thing as development tasks. It's hard to say this research article will be 5 points, so that was a difficult aspect. Additionally, we omitted stand-ups and retrospectives. The omission of stand-ups limited our visibility amongst teammates, and the lack of retrospectives limited our ability to optimize process. Also, we occasionally missed some SE deliverable due dates because we were prioritizing the sponsor deliverables. And also, we came up with 2 process metrics regarding the efficiency and completeness of our research tasks, but we did not find those to be helpful, and we discarded them. And so, for the next term, we plan to complete the prototype, including NFC for key exchange, local device encryption, implementing the attacks, and finally finishing the research paper and having it in a state that can be submitted for publication.
Thank you, guys. So what we just went over were our project background, the domain of body sensor networks, our process and methodology, our secure architecture, and the design decisions that we made according to it, a reflection of what went well and what didn't, and what we plan to do going forwards in our summer term. Thank you very much. Are there any questions? Oh, wow. Let's start from the right side of the room.
I actually have 2 questions here. First, can you again go over what's novel about your architecture compared with how my smartwatch does the same thing with my phone?
Sure. So essentially, standard Bluetooth or Bluetooth Low Energy, which is what the smartwatches are using, encrypt using the default Bluetooth Low Energy standards, which there are 3 different modes of encryption for that. Generally, the first 2 are the ones that are used for most devices because they're easy to implement and they're easy for users to interact with. However, both of those modes have serious flaws in how the data gets transmitted, such that the attacker tool can essentially read anything that gets transmitted. Since our goal is to securely send the data such that it can't be read, we have to implement a the third mode of operation there, which would be in essentially an out-of-bandwidth connection. Since we don't have the tools to implement that with the peripheral devices, they have to only be using Bluetooth Low Energy because of our hardware constraints. We decided to go with a software implementation of encrypting the channel.
And then, a second question, is there a particular reason you, it seems like you're rolling your own protocol rather than applying transport layer security with certificate pinning over the Ethernet channel?
Can you repeat the question?
Well, okay, no.
So it sounds like you're rolling your own protocol over the Ethernet channel. Is there a particular reason you're not using transport layer security with certificate pinning over that protocol, which is a known good transport layer security suite as what underpins TCP5 and HTTPS?
So part of the Bluetooth stack already implements that security layer. We're adding application layer and encryption.
That's the short answer. Sorry.
So do you know the technologies and skills you'll have to procure for next semester in order to test like replay attacks, or how are you going to do that? What tools are you using?
So right now we're using a Linux machine because the tools only work on Linux. We had to procure a Bluetooth dongle, which is acting as a second device on one machine. So we're then using one machine to spoof both devices, and then both devices are, and then we're using a library called Attacker on NPM, which requires like Blano and Noble to set up the connections, and then all it's doing is essentially is reading and recording, and then you can set up varying hooks within any of the service data that you get back from the devices. Yeah, we have essentially everything we need. We might need more, who knows, but that's come to discover in the next semester.
Let's thank the team.
So I'm going to start off by apologizing for having 3 of the same slides basically in a row. That was totally an accident. But we are Team Edgy, and our project is the Cellular Network Crowdsourced Performance Metrics. And I'm Jake.
I'm Ethan.
And I'm Joe. And our coach is Rick Weil. And our sponsor is Clark Hotchcraft. He's a professor at the Electrical, Computer, and Telecom Engineering Tech Department. And we'd also like to take just a minute and thank Professors Nygate and Johnson for helping us out with some domain experience, and also the various graduate students that helped us throughout the project. So this map should hopefully look familiar to most of you, but there's a lot of problems with it, aren't there? So we don't really know what we're looking at. We don't know if that's where you can send a text message. We don't know if that's where you can make a phone call. We don't know if you can watch HD video there. There's really no indication of quality. And there's also, we don't know if this is from the daytime or the nighttime, and that matters because you'd expect as the network gets more congested, you'd probably get worse quality. We also don't know if this is just an, is this an average, or is it the best result they've ever recorded for those places? So let's take a look at the data that Verizon, AT&T, Sprint, and T-Mobile put out to help us answer those questions and put our minds at ease. And of course, there isn't any. So our project is to hopefully crowdsource that data that's needed to answer those questions. So consumers want to know if they're getting what they're paying for. And informing the public can lead to improvements in both quality of service, it can lead to healthier competition, even maybe some more honesty in the claims and the commercials that we see. And so researchers can also use that data to look for patterns, maybe identify problem areas where there isn't great coverage, or even find ways to improve the network efficiency. So to help meet those needs, our sponsor had a few requirements in mind right from the beginning. And part of the initial request was that we take an existing app and decide whether to refactor it so it'll support new types of collection, or to throw it away and start totally from scratch. We chose to keep the existing app and refactor it, and we'll talk more about why we think that worked out later. So the two metrics they were most interested in were bandwidth testing speeds and call quality, and bandwidth needed to be checked for both upload tests and download tests. To determine call quality, we're going to track the signal strength throughout the duration of every phone call that you make. We also track passively in the background signal strength every so often. And so in order to comply with Human Subjects Research Review Board, we had to anonymize all the metrics we collect, all the data. So we're not allowed to track your phone number, the device IMEI, pretty much anything that could uniquely be traced to a user or device, we're not allowed to track. The only thing we do track is the Android version of your device. And finally, as a secondary goal, we wanted to come up with basically a reason for the users to install the app and give us their data. And we really had no idea what that was going to look like at the beginning, so we kind of stuck that on the back shelf and prioritized getting a system that would collect reliable data and good data. And so our solution for that was to implement a system that does both background and active testing. So you can run a bandwidth test, on demand, see how it did. It's also set up to run at specific intervals, and you can configure that interval so that we don't drain all your data for the month. And we wanted to crowdsource this data, so we knew kind of towards the end of the project we hadn't really come up with much for visualization or any kind of user incentive. So in the last few weeks we had two main features that we created. And the first one is a test comparison feature, so you can run a bandwidth test and then tap on the results and see how it did against other carriers in your area. You can also compare that test against your own carrier to see if they're maybe not treating you as well as they should be. The app can also display a tile map, so there's a bunch of tiles overlaid on top of a Google Maps interface, and that shows the average bandwidth speed per that tile. And you can filter that by carrier, and we'll be showing that off during the demo. So the final resulting data set is going to be used by researchers to hopefully find new ways to innovate and even improve the network technologies themselves. And so now Ethan's going to go over our architecture.
So our architecture is pretty simple. The main piece of it is the Android application, which will be installed on the user's phone and will collect the information off of that phone. There's also a bandwidth server that will send and receive random bytes and perform timing on those to collect information about the bandwidth of the phone's connection. Then there's a Flask server, which just provides an API for the Android application to upload the data that it's collecting into the database. And also serves the aggregated results for the heat map and whatnot. And then off the end, the database, there's several different tools that could be used to analyze like R and whatever different analytics you want to use. But one big program that our researchers have been using is a program called Tableau, which helps analyze and visualize the data that's collected. So we chose to use an Android app primarily because our sponsor already had a proof of concept app working for Android.
This proof of concept app was really rudimentary. Basically, just took a log of what different cell towers you could see in the signal strength and whatever. But to get that data off the phone, you had to put in your email address and have it emailed to your account, and then parse through all this big, huge text file. So it was really unwieldy and didn't really meet any of the requirements that we wanted to provide. But we decided to build off of that rather than starting from scratch, so that we could start delivering features essentially from week one. One of the important design decisions we had to make when building the app was the trade-off between battery usage and data collection. In order to appeal to end users, of course, we can't drain their battery too quickly or use up all their cell data. So we have to, be careful about how much testing we're running and stuff like that. But also to be useful to the researchers on the other end, we want to collect, as much high-quality data as we can. So finding a balance in between those two extremes was really important for us when designing the app. On the back end, we used Postgres because it was a technology that our team had experience with, and it's proven and can handle the large amount of data that we'll hopefully be collecting. The bandwidth test server was broken out into a separate server from the collection server because the performance of the test server is really important for obtaining accurate bandwidth results. So it'll need to scale quickly and be deployed to different areas around the US in order to provide accurate test results. And then Flask was used as the framework for our collection service, just because it's easy to deploy, it's lightweight, and that was pretty much all that we needed. That service doesn't really do much other than collect the data from the phone. Currently, the collection server is deployed to a server in the ECTT department because that was just easiest for us to set up, and our sponsor wanted us to keep all the data locally while development was still ongoing. But Flask will allow us to easily deploy it later to AWS or some other cloud provider. So this diagram sort of describes the schema of the different types of data that we collect. On the far left, or your right, you can see the passive data, which is just at the root, it's just one event, which is just a timestamp and a location, and then the set of towers that are visible at that time and their signal strength and whatever. And then during a phone call, the app will group all those events together into one object so that researchers can analyze if you're moving, how the phone handles the handoffs between different towers as you enter and leave areas covered by different towers. And then the bandwidth test, basically at its root, is just a measurement of, this is the speed recorded this time in this area. But we also collect an event at the beginning and end to show sort of like what towers are in the area, so you get a feel for like what towers were being used. And then it's also collected, we collect a list of intervals during the test, and each interval is just a 200 millisecond slice out of the test that shows, the bandwidth that was achieved during that slice, so that researchers can see, how the bandwidth changes over a long transmission. And again, just to hit that point on the head, all this data that we're collecting is anonymized.
All right, so now I'm going to take you through a quick demo of our Android app. I'll start off by saying that all of the data that a user could download our application and never even open it, and we'll still collect all of our information that we need. But as Jake said earlier, we wanted to provide some sort of incentive for the user to want to download our app. So when they open it up, this is what they'll see. Similar to any other speed tester, we have a large dial in the middle with a needle that will indicate what the speed of the test is. And at the bottom, we have two options. We can either run a download test or an upload test. So I'll go ahead and I'll start an upload test. And so during this, we have two different phases that we go through. We go through the initial phase is a warm-up phase. And so during this, we send a series of small packets that increase in size, and then we wait for it to take at least half a second for the server or the phone to receive it. And then with that, we can kind of gauge what the speed of the connection is, and then using that data, we calculate larger file size that the phone or the server will receive. So with this, we can see that we got about 30 megs for our upload test,
And for users that want to know more about how the test performed, there's also this log button. So this just shows all of the different intervals that occurred during that test. So you can see at the beginning we had a bunch of warm-up tests. And then after, like right here, we calculated the main test file size, and then we ran the actual main test. So there's a lot of data here, and all of this gets uploaded to our web metric service. So researchers can go back through and analyze every step of the process. So you may be wondering, can I go back and see all of my previous data, or my previous tests? And you can by going to this My Results tab. So this is just a list of all the previous upload or download tests that I've run on the phone, both automatically and manually. And so for each result, you can see the speed of the test. You can see what time it ran at. You can see if it was a download or an upload test. And most importantly, you can see how much data we actually used during that test. So this way users know that we're not, chewing through half of their data plan to do one test. So this answers the question of how is my phone doing, but we also wanted to be able to answer the question of, is there a better option for me? So by clicking on one of these results, it brings up this dialog, and this loads all of the averages for the 4 major carriers in the area that the test was taken in. So with this, we can see AT&T had the best speed, followed by Sprint, T-Mobile, and then Verizon. This data isn't completely accurate, so take it with a grain of salt, but that gives us a gist of it. So, and then that's good for comparing your carrier against all the other carriers, but say that you are going on a road trip and you want to see, can you stream music the entire time or watch a movie? So if you go to the map view, this is where we load all of our aggregated data. So we'll take all of the points that are inside of a tile, average them, and then display that on this map. And each tile is color coordinated, so the red tiles indicate a worse bandwidth speed, and then it goes all the way up to a green color. So with our aggregation, we also do it at multiple different zoom levels. So as I zoom in, you can see that the tiles are updating and they're getting smaller. So looking at the map of RIT, we know that there's a cell tower in Eastman, and we can see that towards the center of RIT, the data is more green than on the outside. So that's indicating to us that our tests are actually doing what we want them to do. And I can continue zooming in here to get pretty fine resolution. So looking at University Commons, we can see that one tile is about the size of one of the UC houses. So we also then have some different filters that we can apply to our data. One of those being the day or time of day. So you could look and see what the speeds are in your area for peak hours or in the middle of the night. And then another one that we have is you can choose which carrier you want to look at. So we were just looking at the Verizon map, but if I switch to AT&T, we can see that that data has now updated. And we did have a couple other filters that we wanted to be able to have on this that were stretch goals for us, such as being able to filter by upload or download test, or what the signal strength of call was. So one of our other screens is just a simple about page. This just lets people know what we're doing with the app, or what we're doing with your data and how it's working. And then also at the bottom we have some developer options. And this just indicates to us how many records are being stored on your phone. So every time a test runs, we store it locally on the phone in an SQLite DB. And the reason we do this is if a test runs when the phone doesn't have a connection, we still want to be able to upload that data later. And so with this, we can also force an upload of all the data on a phone. And then lastly, we have some configuration options. So with this, users can tweak how much we actually collect. So one of the first configuration we can change is the passive tower data collection. And so this just means how often do we look up all of the visible towers in the area that the phone can see and the signal strength. And that defaults to 15 minutes.
Another one is the bandwidth test frequency. So this is just how often a download and upload tests are done. And this defaults to 11 hours, but some people might only want to do it once a week, or in our case, we were setting it to 1 minute and driving the loop to get a bunch of data. And then lastly, we have bandwidth test max file size. And so with this, we can just set an upper limit on how big of a file we want to send during a download or an upload test. So this defaults to 20, but a user could change it as they see fit. So that's pretty much it for our demo. Some of our challenges this semester or during this project were losing a team member. Originally, we had slated a lot of the visualization and the GUI to our fourth team member, but after losing him, we negotiated with our sponsor, and originally we actually weren't going to do anything with the visualization, but he wanted to be able, towards the end of the semester, start getting funding for the app. So we took on that extra work and got something to show for it. So another one is big data aggregation. No one on our team has ever done anything with spatial or temporal data, so that was a challenge. And then just also a lack of initial domain knowledge. Cellular networks use a bunch of crazy 3-letter acronyms that are 1 letter off from each other. So that was kind of hard to wrap our minds around. And then also phones not supporting some technologies. So a lot of, because we're running on Android, phone manufacturers can implement anything how they see fit. So oftentimes we get something working and then send it out for the rest of the team to test, and it just wouldn't work on everyone's phones. So we had to go back and redo some stuff multiple times. And then also just how to do a bandwidth test. Originally we were going to just always send a 1 megabyte file, but that was not really working out. So we had to go back and figure out how to scale that, or scale our test based on the speed of the phone.
So overall, the project went pretty well. We kept our sponsors really happy pretty much the whole way through the year by meeting with them frequently and keeping them involved in the process. We also performed occasional code reviews to give them insight into how things worked and hopefully ease the transition as it's handed off back to them. But in addition, we also created a stable, fully functioning system that even if this isn't taken on, as a project next year, this app will still be able to be used to collect lots of, high-quality data for researchers to analyze. Additionally, our team worked really well together. We got along well together, and our different experiences really helped us cover all the different aspects of the project. And it was really helpful having those analysts and domain experts actively assisting us. Looking at the data that we're getting, saying if it's, like good or bad, like what we should be getting, how we should be collecting it. And then in addition to that, they also just helped act as a sort of a pool of beta testers to give us quick feedback on how things are working. But of course, it wasn't all perfect. At the start, we didn't really have a well-defined process outside of meeting every week with our sponsor. So outside of that meeting, there was really no way for him to gain visibility into what we were working on, what our progress was, or to assign us new tasks or anything like that. So we've solved that partway through the first semester by using Trello to track all our tasks. In addition, the requirements at the beginning were fairly vague. Besides, just collect data, like it wasn't really fleshed out how we were going to incentivize users to install the app. But in the beginning of the project, we tried to, build a full requirements doc anyway and elicit all the requirements needed, but that didn't really come together. And as we, delivered more functionality, the sponsor, got a better idea of what he actually wanted and what could actually be done with the app. So things just sort of solidified as it continued. And in the future, of course, there's always more work to be done. The scalability of the servers is, currently not really tested or proven. It's all, running locally here on the RIT campus. But if this is going to go, nationwide or worldwide, we'll need bandwidth servers and collection servers running all over the country. We also need to create better incentives for users to actually install the app. The heat map and the comparisons are a great start, but we could use, more intuitive comparisons or better visualization of the data, or visualization of some of the other data that we're collecting besides the bandwidth. The data aggregation system also needs a little work, we can move it from a table in Postgres to its own data store. And of course, there's always more analysis that can be done with the data that we're collecting. There's always, more research that could be looking into that. So if you'd like to join our beta and help us collect data, you can go to this URL, join.edgy.tech. Any questions? Yeah, go ahead.
I have a couple questions. So you say that the data is anonymous as far as user and everything like that, but are you collecting the location at the time?
Yeah, so in order to get, information about, bandwidth in different areas, we have to collect the user's location. And right now, with there being only, 4 or 5 users, you can say, okay, yes, there is a bandwidth test here and then here. And you can sort of track, so it's not perfectly anonymous. You could still draw inferences from the data. And that's one of the reasons why the full data set isn't available publicly.
Okay. And so I noticed that the map was based on red and green and a scale kind of between those two. It just seems like that might not be great for accessibility for colorblind people, since that's one of the main colorblind areas. Do you have an idea of a different set of colors that you might use, or would you just go for red and green?
So originally what we wanted to do was kind of have a dark to light for the carrier. So Verizon would be red, AT&T would be blue, that sort of thing. We just didn't really have time to implement that.
That's a good point. I appreciate you bringing that up, though. But yeah, again, visualization was originally out of scope. And then as we neared the end of the project, we found that we had enough time to actually build it in. So, yeah. Go ahead.
So you said your app would work even if the user never opens it. So how are you handling permissions? I'm not sure exactly how it works on Android, but if they don't open the app, how can they accept the permissions to allow the location and all this other stuff to be happening when the app isn't in use?
Yeah, so technically you will have to open it exactly once to accept the permissions. Like Android doesn't allow any background services to run until the user has actually opened the app after installing it. So you will have to run it at least once.
But then you can just leave it.
But outside of that, yeah, you can ignore it. Yeah?
Where exactly all of the impacts of having that app running in the background are, such as performance, CPUs, the data stuff. It's 20 megabytes every 11 hours that can really add up.
Yeah, so that was one of the big concerns in designing it to be friendly to users actually installing it. Initially in the project, when we first started building it, battery was a huge issue because we were tracking location very frequently, and we fixed that by scaling it back to every 15 minutes. And yeah, like you said, it will use your cell data in the background, so that's something that the user would have to watch, and if it's using too much, then to scale back the frequencies. But really, there's no way to get around that. We can't test the bandwidth of the cell network without actually putting data over the network.
Let's thank the team.